Assalamualaikum and hi. We are from CS112, Group A4 CS1121B. Today, we are going to present about our MAT183 Assessment 2 video presentation, Techniques of Differentiation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad RAFIQ bin ROSLI. Student ID number 2025468788.
Assalamualaikum warahmatullahi wabarakatuh. My name is DZAFRAN bin DZULKARNAIN. Student ID 2025405696.
Hi, my name is Muhammad Darwish bin Abdul Wahid, student ID 2025213174. Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. What is meant by differentiation? Differentiation is the process of finding the instantaneous rate of change of a function with respect to one of its variables, which is equivalent to finding the gradient of a curve at any given point. Differentiation calculates how a function output change as its input change. For a function y equals to fx, its derivative written as f prime x or dy over dx give the rate of change of y with respect to x. Okay, let's take a look at question number 2. Find dy over dx for the following functions. A. Y equal to 9e power of x tan x minus 3. B. Y equals to x squared plus 1 over sin x. Question A. Y equals to 9e power of x tan x minus 3. So, we will use product rule for this equation. dy over dx is equals to u v prime plus v u prime. So, we must find u prime, v and v prime first. We will let u equals to 9e power of x. So, if we differentiate 9, will become 9. E power of x will still remain the same as e power of x. Then, we'll differentiate x, so it will become 1. So, u prime is equal to 9e power of x. After that, we'll let v equal to tan x minus 3. We differentiate this equation. Tan will become sec square and x minus 3 will remain. Then we differentiate x minus 3, it will become 1. So v prime is equals to sec square x minus 3. After that, we will substitute u prime, v and v prime into the formula of product rule, which is u v prime plus v u prime. So, we will get 9e power of x times sec square x minus 3 plus 9e power of x tan x minus 3. As we can see, we can factorize 9e power of x. So, the final answer will become 9e power of x bracket sec square x minus 3 plus tan x minus 3 close bracket. For question B, y equal to x square plus 1 over sin x. For this equation, we will use quotient rule. dy over dx equal to v u prime minus u v prime over v square. First, we let u equal to x square plus 1. After we differentiate, x square the 2 will move forward. So it will become 2x. And as we know, after we differentiate x, the power will be minus by 1. So it will become 2x. What happened at the plus 1 at the back? As we know, any number that doesn't have x, it will become 0 after we differentiate. After that, we let v equal to sine x. Sine, after we differentiate, it will become cos. So, sine x, if we differentiate, it will become cos x. After that, we will substitute u prime, v, and v prime into the question formula, which is v u prime minus u v prime over v square. So, it will become sine x times 2x minus x square plus 1 times cos x over sine x square. So, we need to expand. It will become 2x sine x minus cos x, x square plus 1 over sine square x as the final answer.
Next, for question 3, given ln y plus sin squared x squared plus e power of y equals to 5xy, find dy over dx using implicit differentiation. So we need to differentiate all of the equation. So first, we differentiate ln y. Ln y, we differentiate will become 1 over y. Differentiate y will become dy over dx. Secondly, we need to differentiate the sine squared x squared plus e power of y. We need to use the chain rule to differentiate it. There's 3 steps for this differentiation. First, we need to bring down the power of 2 to the front. That's the first step, and it will become 2 sine x squared plus e power of y. Next, we differentiate sin squared x squared plus e power of y. We differentiate it and will become cos x squared plus e power of y. After that, we need to differentiate again the x squared plus e power of y. So the answer for that is 2x plus e power of y differentiate y dy over dx. So the thirdly, we differentiate 5xy using the product rule. So the formula for product rule is u v prime plus v u prime. So first, we need to let u equals to 5x, meanwhile v equals to v equals to y. So differentiate u become u prime equals to 5, differentiate v will become v prime equals to dy over dx. So for the third row, we need to multiply the 2 sine x squared plus e power of y cos x squared plus e power of y with 2x plus e power of y dy over dx. So it will become 4x sine x squared plus e power of y cos x squared plus e power of y plus 2e power of y dy over dx sine x squared plus e power of y cos x squared plus e power of y. And for the fourth row, we need to move all the variable of dy dx to the left and non-dy/dx to the right. So if we move all dy/dx to the left, we will move the 5x dy over dx to the left. It will become negative 5x dy over dx. So we move non-dy/dx to the right. We move 4x sine x squared plus e power of y cos x squared e power of y to the right. It will become negative 4x sine x squared plus e power of y cos x squared plus e power of y. For the fifth row, we need to factorize the dy over dx. We factorize it and it will become dy over dx times 1 over y plus 2e power of y sine x power of 2 plus e power of y cos x squared plus e power of y minus 5x. Next, we need to move the multiplication to the right. So we move 1 over y plus 2 power e power of y sine x squared plus e power of y cos x squared plus e power of y minus 5x to the right. So multiplication, we move to the right, it will become division. So dy over dx equals to 5y minus 4x sine x squared plus e power of y cos x squared plus e power of y divided by 1 over y plus 2e power of y sine x squared plus e power of y cos x squared plus e power of y minus 5. So that is the answer for the differentiation. So we have the answers for the dy over dx. But if you want to make the denominator without the fraction, we need to times it by y over y. That it means 1. So if we times y over y, it will become 5y squared minus 4xy sine x squared plus e power of y cos x squared plus e power of y divided by 1 plus 2ye power of y sine x squared plus e power of y cos x power of 2 plus e power of y minus 5xy. Okay, that's it for question 3.
For question 4, we are asked to use linear approximation to estimate the value of 8.02 power of 2 minus cube root 8.02 cracked with 2 decimal. So for this kind of question, we will use the formula fx naught plus dx approximately fx naught plus f prime x naught times dx. First, we rewrite the expression as a single function fx equal to x power of 2 minus cube root x. So x is the given value, which is 8.02, and the x naught is a value close to the one we want to evaluate, which is 8. And dx is equal to x minus x naught. So 8.02 minus 8 is equal to 0.02. Then we calculate the derivative. Fx prime is equal to 2x minus 1 over 3 x power of negative 2 over 3. Finally, we substitute the values into the formula. Therefore, we will get 62 plus 191 over 12 times 0.02. Then we will get rounding to 2 decimal place give 62.32. So the conclusion is, technique of differentiation are fundamental tools in calculus that enable us to determine the rate at which quantities change. Mastery of these techniques, including the power rule, quotient rule, and chain rule, provides a structured approach to finding derivative and deepens our understanding of how functions behave in mathematical, physical, and real-world contexts. Ultimately, differentiation techniques form the backbone of mathematical analysis and are essential in fields such as physics, engineering, economics, and beyond. That's all from us. Thank you.